Geometry, Unit 3, Lesson 6. I can identify and use properties of kites to solve problems. So, using a protractor to measure angles and then a ruler, in class you'll be asked to investigate the quadrilateral and try and see what you can come up with. For the sake of time, we're just going to look for those relationships right now together. For the sides, the interesting thing is you'll notice that consecutive means like one after another. So there's this pair of consecutive sides right next to each other there. They're congruent, while this pair over here is congruent too. But notice not to each other, because this one's longer than this. You'll also notice that none of these sides are parallel. Absolutely none of them. These might kind of sort of look like they are, but if you really look closely, if they do this, they get closer and closer together out there. So the major relationship here for the sides is that we have two pair of congruent consecutive sides. And there's no parallel sides. That's a big deal. So is this possibly a parallelogram? Absolutely not. Now, if we look at the angles, there's actually a lot going on. And, or check this out. Okay, these guys right here, I like to dot my vertex and arc the non-vertex angles. So this is the vertex angle, this is a vertex angle, this here is a non-vertex angle, and this is a non-vertex angle. You can see the vertex angles, they're not the same. The non-vertex angles, however, are. So the main relationship here is that non-vertex angles are congruent. Okay, that's the big thing we've got going for us there. And the diagonals have the most going on. And so if that was my angle relationship, here's my sides relationships. If we take a look at the diagonals, the first thing that probably jumps out to you is that they're perpendicular. And indeed they are. That's the first thing. Now, the next thing is that we need to be really careful. They don't bisect each other. The vertex diagonal bisects the non-vertex. So this big, long vertex diagonal here only bisects the non-vertex angle. So, vertex diagonal bisects non-vertex diagonal. And then the last big thing is that this non-vertex diagonal, you can see, doesn't bisect this angle. This one's smaller than this one. But the vertex diagonal does bisect the angles here. And so what you end up getting out of here is that angle has been bisected, and that angle has been bisected. So you have the vertex diagonal bisects the vertex angles. So those are your major relationships going on here with a kite. And you can kind of think about it, if you folded right down the vertex diagonal, this would fold perfectly on top of that. It's symmetrical. That's a line of symmetry right there. But that would not work that way. So we're just going to look at a couple problems. And there's one thing we need to know, and that happens to be, we have to bring it in now even though it's a unit early. The sum of the interior angles of a triangle, I'm guessing most people know, and we'll prove it later, but is 180. If you do A plus B plus C, A plus B plus C is 180, so it's supplementary, the interior angles of a triangle. Now the interior angles of a quadrilateral, you might have already noticed, but it's really two triangles. So if this plus this plus this is 180, and then we finish this angle with another for another 180, you can see these two pieces make the whole angle in the quadrilateral, you get a total of 360 degrees. And we're going to need these two relationships to help us find missing angle measures. So if I come down here, remembering that a triangle sums to 180 and a quadrilateral sums to 360, let's see what we have. We're just going to do this first row real quick. Solve for the missing variables using what you know about the properties of a kite. We have a kite. Okay, it's implied that each of these is a kite, therefore this one already we know is a kite because it has the two pairs of consecutive sides congruent, and we have to figure out the measure of angle K and J. So I'm going to go down here and put the measure of angle K equals, the measure of angle J equals, just to kind of remind myself in my solution box. Now, if you look at this, it's a quadrilateral, and you can tell it's a kite, which means you know I like to dot my vertex and arc my non-vertex. And so if this is 115, angle K is also 115. So the question is, what's angle J? And the way you go about doing that one is you realize it's quadrilateral, so all four angles must sum up to what? 360. And so you'd get 55 plus 115 plus 115 plus the measure of angle J is equal to 360. And if you go ahead and add them all up, I think you get, let's see, that's 230. That's going to be 285. And then if I take 285 from both sides, the measure of angle J is going to be, I think, 75 degrees. And there you have it, 75 degrees. So the same idea applies here. If you want the measure of angle E, and it's still a kite, so they're telling me it's a kite, so I can again dot the vertex, arc the non-vertex. If I don't know what they are, I can just call them X, but they're both X. And so you're going to get the same relationship here, that the four angles in a quadrilateral sum to 360. So what I can do to write an equation for this one is say X plus 110 plus 50 is equal to 360. So 2x plus 160 is 360. Take 160 from both sides. 2x is 200. Divide both sides by 2. And x is 100. I was trying to find the measure of angle E. I did indeed find that it is 100 degrees. The only thing you need to know about triangles, if you look in here, I want x and y. So I'm not done until I have both of those. So I'm going to put x equals and y equals at the bottom. And if I zoom in on this last one, you know it's a kite. So you're allowed to do a whole lot of things, including say this is 90. Now, let's see what else we can mark up. You know this right here, the vertex diagonal. Dot the vertex, arc the non-vertex. You know they bisect the angles, so this has to be 41. This is 90, this is vertical, so that's 90. And now take a look at this triangle right here. I can kind of take it off and put it right there. You've got 41 there, you've got 90 right there, and then you've got y right here. So 41 plus 90 plus y has to equal 180. Okay, a triangle's supplementary. So you get 131, and if you take 131 from both sides, I believe you're looking at 49 degrees for y. We're going to do the similar approach for x, 78 plus 90 plus x, and then you're good to go. 78 plus 90 plus x equals 180. And if I finish that off, I'd end up getting, I think, 12 degrees is x. So remember, you need to see that the interior angles of a triangle add up to 180, while the interior angles of a quadrilateral add up to 360, because there's two triangles in there. And the other good practice is to dot your vertex and arc the non-vertex angles. Good luck.